Welcome to this Mastering EAI Patterns course. Before we start, let me tell you who I am and why I believe I can help you master integration development. My name is Ari Wilkman. I've been working in the IT field for over 25 years. For the last 8 years, I've worked full-time as an integration architect. Before that, I was a developer like many of you. My background is in back-end development and system integrations, but I didn't always understand integrations the way I do now. When I first took full responsibility for integration architecture around 2017, I faced total chaos. Projects were overlapping. Communication between systems was unclear. Developers were stuck with one-off point-to-point connections. Everyone was confused about what integration really meant and who should do what. That experience changed me. It made me realize that integration is not just about code. It's about clarity, design, communication, thinking in systems. Since then, I've led or been closely involved in over 100 integration projects, ranging from finance and public sector to e-commerce and healthcare. I've learned what works and what causes projects to fall apart. And I've turned all that knowledge into this course, to give you a shortcut. This isn't a theory course. It's the result of real work, real projects, real patterns that help you deliver better outcomes. Let's talk about what integration actually means in real life. The term you'll often hear is Enterprise Application Integration, or just EAI. This is not just a buzzword, it's a way to describe how separate systems inside a company can work together. Most organizations don't run on one big system. They use many smaller systems, one for sales, one for logistics, one for finance, and so on. These systems don't speak the same language by default. They don't understand each other. That's where integration comes in. EAI is about creating bridges between systems, so that data can flow, actions can trigger other actions, and everything feels like one connected environment. Without integration, data stays stuck in silos. Teams copy things manually from one system to another. That causes delays, mistakes, and frustration. But with good EAI in place, you can automate those flows. You can connect customer data, order data, product info, and make them work together. So when someone updates a product price in one system, that change can automatically show up everywhere else. This kind of integration saves time, reduces errors, and lets businesses move faster. That's the core of EAI, making sure that your systems aren't just running, they're running together. Let's make this more concrete with a few real examples. First, think about an online store. When a customer places an order, several things need to happen. The order system must confirm the order, the inventory system must check and reserve stock, and the payment system must process the transaction. Without integration, someone would have to do all of that manually. With integration in place, all these systems work together automatically. Second example, in healthcare. When a doctor enters patient information into a hospital system, it often needs to be sent to multiple systems, like lab systems, billing systems, and national health records. That data must be synchronized, secure, and accurate. EAI makes that happen. One more, logistics. When a shipment leaves a warehouse, the tracking system updates the customer portal, the invoice is generated, and the inventory is updated, all through integration. The point here is this: EAI is everywhere. In retail, finance, government, telecom, banking, insurance, if systems need to talk, integration is involved. These are not edge cases. This is the everyday reality in almost every modern organization. Let's wrap up this lesson with a quick recap. First, we introduced the idea of Enterprise Application Integration, EAI, which is all about making different systems work together. You saw why this matters. Without integration, data gets stuck, work becomes manual, and everything slows down. With EAI, we connect systems, automate flows, and support real business processes. Then we looked at real-life examples: online shopping, healthcare, logistics. These are not special cases. Integration is everywhere. So now you should have a clear picture of what integration is and where it's used. In the next lesson, we go deeper into the actual integration patterns, the core models that help structure communication between systems. Thanks for following along. See you in the next lesson. Welcome to this lesson on core integration patterns. This is one of the most important lessons in the entire course, because here you'll learn how to think like an integration developer. In this lesson, we'll go through the most common patterns used to connect systems in real life. You'll learn what problems these patterns solve and where each of them fits. By the end of this lesson, you'll be able to describe 4 key patterns: message broker and pub sub, request response, routing and transformation, and aggregation. You'll also see how they compare and when to choose which one. Let's start with one of the most used and most flexible integration patterns: message broker and publish subscribe. This model solves one of the most common integration problems: tight coupling between systems. In a basic integration, one system sends data directly to another. That works, but it creates a dependency. If the receiving system changes or goes down, the sending system can break. In the pub-sub model, we add a message broker in the middle. The sender, also called the publisher, sends messages to the broker. The broker then forwards the message to one or more subscribers. The sender doesn't need to know who the subscribers are or even how many there are. That's the power of this model. It decouples systems. It allows flexibility. It also enables multiple systems to react to the same message. A good example is a new order event. The order service publishes the message. Then inventory updates, billing starts, and a confirmation email is sent, all triggered by the same message. No system talks directly to another. That's pub-sub in action. This pattern is the foundation of event-driven architectures. You'll see it everywhere, from retail to finance to IoT. Now just remember the core idea. Pub-sub removes direct connections and makes integrations more scalable and reliable. Now let's look at a very familiar pattern: request response. This is probably the most common communication model in software, especially in web services and APIs. The idea is simple. One system sends a request and waits for a response. You ask a question, you expect an answer. A typical example is a front-end application calling a back-end API. It sends a request to fetch user data, and the back-end replies with the result. This model is easy to understand and easy to implement, but it comes with trade-offs. First, both sides have to be available at the same time. If the back-end is slow or down, the front-end just waits or fails. Second, request response creates a tight connection between sender and receiver. They depend on each other. If the response format changes, it can break the client. So while this model works well for simple and direct interactions, it doesn't scale well for complex systems with many moving parts. It also puts pressure on availability and performance. That's why in modern architectures, request response is often used together with other models, not alone. The key takeaway here is this: request response is perfect when you need a direct answer right away, but for large-scale, loosely coupled systems, other models might be a better fit. Now let's look at 2 patterns that often go hand in hand: routing and transformation. Routing is about deciding where a message should go. Transformation is about changing what the message looks like. Let's start with routing. Imagine an integration where messages from one system need to be forwarded to different target systems depending on their content. For example, invoices should go to the finance system, while support requests go to the help desk. That's routing. You inspect the message and send it to the correct destination. The logic can be based on message type, content, headers, or any other condition. Then we have transformation. In most real-world integrations, different systems speak different languages. One system sends a message in XML, another expects JSON, one uses euros, another uses cents. Transformation changes the structure or content of the message so that the receiver can understand it. Often these 2 patterns are used together. First, we route the message to the right place. Then we transform it into the right format. Without these steps, systems would constantly fail to understand each other. So, routing makes sure the message gets to the right place. Transformation makes sure the message is understood when it gets there. Simple idea, but absolutely essential in integration work. Let's now look at the aggregation pattern. This pattern is all about combining multiple messages into one. Why would we need that? Because in real integrations, data often comes in pieces. One system sends part of the data, another system sends the rest. The receiving system, however, needs a full view, one complete message. Aggregation solves this by collecting related messages and merging them together. A simple example is order processing. Let's say product details come from one service, customer information from another, and payment confirmation from a third. The system that handles shipping can't do its job until it has all three. The aggregator pattern waits for all parts to arrive, then combines them into one message, ready for the next step. Aggregation often involves correlation logic. That means the system needs to know which messages belong together. This can be based on an ID, a timestamp, or a specific flag. Once all required parts are received, the system can continue. Without aggregation, systems would either miss information or act too early. So, to summarize, use aggregation when you need to wait for multiple inputs and deliver a single, complete result. It's a crucial pattern when working with distributed or event-driven systems. Now that we've gone through the key integration patterns, let's take a moment to think about when to use each one. The answer depends on the problem you're solving. PubSub is great when you want multiple systems to react to one event without knowing about each other. Request response works when you need a direct answer right away. Routing helps when messages need to go different places depending on their content. Transformation is needed almost everywhere because systems rarely speak the same format, and aggregation is critical when you need to wait for multiple inputs before taking action. So how do you actually implement these patterns in code? That's where tools like Apache Camel come in. Apache Camel is a lightweight integration framework that supports all the patterns we just covered. It provides built-in support for message routing, transformations, aggregations, and more, all using readable and efficient integration flows. If you'd like to see how these patterns look in practice, we explore them in our full course, Mastering Integration Development. But for now, the key is to understand what each pattern does and when to use it. That's the real foundation of smart integration design. Welcome to the final lesson of this mini-course. Over the past few lessons, you've explored the core concepts of Enterprise Application Integration, or EAI. We started by understanding what integration means in the real world and why it's essential for modern organizations. Then we looked at real-life examples where integration plays a critical role, from online shopping to healthcare and logistics. You learned why shared language matters in integration work and how miscommunication between teams can lead to costly mistakes. And most importantly, we introduced the 5 essential EAI patterns: PubSub, request response, routing, transformation, and aggregation. These patterns form the foundation for integration design. They help you solve common problems with proven, reusable solutions. This mini-course was designed to give you a practical introduction to the integration mindset and show you how to speak the language of integration with clarity and confidence. Now let's take a moment to reflect. If you're still with me, that already says a lot. You've gone through the essential patterns of integration development and explored how modern systems work together behind the scenes. But how do you know if this field is truly for you? Start by asking yourself a few questions. Do you enjoy solving technical problems that connect different systems together? Do you find satisfaction in building something invisible, something users never see, but that makes everything else work better? Do you prefer practical, real-world challenges over abstract theory? Integration development often attracts people who like to understand the big picture, but also enjoy getting their hands dirty with implementation. You don't have to be a senior developer, but you should enjoy logical thinking, patterns, and making things work together. If that sounds like you, then you're already ahead. If this mini-course sparked your curiosity and you want to go deeper, the next step is clear. Our full course, Mastering Integration Development, offers a structured path to truly mastering integration design, development, and architecture. You'll dive into the role of integrations in modern digital ecosystems and learn the key principles and terminology behind enterprise application integration. But more importantly, you won't just learn, you'll apply. Throughout the course, you'll solve practical design challenges, make architecture decisions, and explore how integration patterns work in real projects. You'll get familiar with different ways to connect systems, from real-time messaging to batch flows and hybrid models. We'll also dig into real-life integration problems like timing issues, message failures, and data quality, and give you concrete methods to handle them. This course isn't just theory, it's built for practice. And just like this mini-course, the full course supports subtitles in many languages. The best part? You can try the entire first lesson for free. Let's keep going together.